Today we have on hand Brian Patterson. Brian is the president of Emerge Alliance. He brings 30 plus years of electrical experience. As a president of Emerge Alliance, he works with prestigious organizations such as the IEEE on standardizing DC power. Brian is a key figure in our Smart Energy Microgrid Pavilion at Solar Power International, and he's heading up that project for us as well. So without any further ado, Brian, take it away.
Thanks, Greg. I'm going to today address it. This is a second in our webinar series, and this particular webinar is about real-time transactional management of microgrid mesh network. We also have available the first webinar we did, which was the next big thing, the internet. That's available online both at Emerge and also at the SPI website. And a quick reminder that there'll be a final in this three-part series, which will be a preview of North America Smart Energy Week, which features the Solar Power International, along with Energy Storage International, Hydrogen Fuel Cell North America, and the Smart Energy Microgrid Marketplace that's facilitated by Emerge. So all of that preview is going to be on August 2nd, again at 2 o'clock, same time, same station, I guess. But today we're going to talk about real-time transactional management of microgrid mesh networks, which is kind of code for the grid of grids, or as we call it, the Enernet, E-N-E-R-N-E-T, which is really sort of the intersection of smart power and smart buildings. So what's happening in the electrical domain these days after 100 years of remarkable and historic success with a traditional grid, actually 3 grids here in the States and more in North America. So after that long history of success with the grids that we have, one question is, well, why do we need to change, or what's changing? Well, we have some disruptors entering the electrical domain marketplace. First of all, inspired by our desire to have a clean planet and clean air and so on, there's the development of economical, clean, renewable energy, most notably, of course, solar and wind. The advent of practical electricity storage, both in form of various technologies of batteries and hydrogen and other types of storage systems. Power electronics, and I didn't finish my thought here, but particularly those power electronics in solid state technology that allow relatively simple articulation of power, particularly between voltages or conversion from one voltage to another. Also the advent of the IoT, or Internet of Things, which really is enabled by low-cost embedded computing capability. There are now literally billions of microprocessors, small computers embedded in a variety of things, everything from the smartphone in your hand to your doorbell and beyond. And all of that is coming to play in this notion that we're going to have a lot more things talking to other things, and sensors and so on. Then there's the really we're on the brink of a major shift in the transportation domain to electric vehicles, and as I call it from an electrical standpoint, it's the mother of all loads, because it will dramatically change the landscape in terms of having to provide electricity for mobile devices on a bulk scale or a bigger scale in terms of numbers of electrons. And we're also at what many describe as the beginning of the end of fossil fuels and other more traditional fuels. We've seen some issues suppress the development of nuclear, issues with oil, natural gas, as some describe it, even in my home state here, Pennsylvania, where we're harvesting a lot of new natural gas reserves. It's really a bridge to nowhere, in a sense that it will have the same ultimate fate as oil and other non-sustainable, non-renewable sources. Biofuels, and I put that in the list here because a lot of people think that biofuels are going to be a big part of the future, and they may play some part in the future, but biofuels do generally consume and use a lot of water, or the use of water, and water is another one of those vital materials that we're going to be short of. So biofuels may see a short life due to the fact that they have such a dependence on the water supply as well, and of course coal. And even though all of these fuel sources will continue to be a part of the system for some time, we think we are at sort of the beginning of the end, as I mentioned. One last piece is big data analytics via the cloud. And I guess it's a little bit of a reference to the fact that the internet now not only includes the transactional elements of the internet between data points and storage and so on, but also between a sort of a simile for the thing called the cloud, which is more and more taking on the role of a place where you can collect and analyze data, big data, for big systems, of which the energy system is. So what's wanted in all of this is a smart world. And a smart world is more than just smart energy. It's a lot of smart things, smart water, smart parking, smart car, smart shopping, et cetera, et cetera. So it's important to understand that smart energy is a component of a bigger picture of a smart world, or as some people say, as it evolves sort of from small to large, from a smart home to a smart building, to a smart car, to a smart city or community, to a smart city, to a smart region, to a smart grid, et cetera, et cetera. So it evolves. And smart energy is a component that shares particularly the informational platform that it will be used with smart energy. So smart energy, as some would describe it, is the electrical system that employs more and more clean energy measures with a lot of devices that have intelligence to result in the use of efficient energy resources, and renewable preferably, in a highly articulated, very flexible, efficient, and most importantly, resilient infrastructure. Some of these attributes are not what we're used to in the electrical system, which predominantly heretofore has been a fixed system, relatively passive in a way, which is one of the ways that it's been so reliable, is it's been simple and passive for the most part. It's now taking on more complexity. But it does require the transport of electricity over long distances and has some vulnerability due to its physical architecture. In any case, what we think we're headed for is something called an internet. I like to call it sometime a grid of grids. We don't use the word network a lot in the electricity domain because it gets confused then with what's happening in information and information technology. But really, what we're trying to do is do for electricity what the internet did for information. The only difference, or one big difference, is that electricity can't be copied, whereas information can. So information we can store and copy and have in a lot of different places. Electricity is more of a use it or lose it deal. Even when it's stored, it has a finite presence, and once you use it, it ceases to exist. You can't make copies of electrons in the way that we do information. So we need a slightly different system that's based on transacting the exchange of electrons for some value, and that's really what the internet, if you will be the more physical infrastructure for that, which will include layers of grids and so on that are linked together in a macro way, but will be accompanied by a set of electrical and communications means and standards to manage it. In general, and what this webinar is intended to be about, is the transactive energy control within that so-called internet, which essentially is being enabled by modern information technology, particularly IoT. When we can embed enough intelligence in things that they can start to operate between themselves autonomously, that's where the whole idea of transactive energy control comes from. So what transactive energy control really means is a system of embedded control mechanisms that can reflect the economic and other values that need to govern transactions, that simultaneously allow a balance of supply and demand across the entire grid, or across the entire internet, if you will. So it's using value as its key operational parameter, although it obviously has to have respect for all the electrical parameters in that balance of supply and demand. But it is a true kind of mesh approach. In any case, the problems that we're trying to solve are many simultaneously. As I mentioned, cars and other reasons, population are the two big reasons that will put a demand on electricity. It's expected that worldwide the use of electricity will double over the next 10 to 15 years. We do have a dependence on fossil fuel that concerns many, not only from an environmental standpoint, but from an independence and availability standpoint. But also there's a resistance to some of the ways that we have to deploy our electrical systems today. So anything we can do to reduce the footprint on the public domain would be an advantage. And of course, the growing problems of resiliency, whether they're man caused or natural or space caused, like EMP and so on. Resiliency is a bigger and bigger issue, mainly because we use more and more electricity and we depend on it more and more for the work that we do and for the environments, to create the appropriate environments for those that we work and live in. In any case, there's also the huge issue of a large and growing underserved population that has no regular source of electricity. I happen to just have come back from some conferences in Kenya and experienced that firsthand as I went out into some of the villages where there is no electricity. In any case, what we're looking for is a solution that really balances the act between environmental and economical and social requirements, something that's equitable to everybody, that's variable in terms of environment and its demands on people, and that it's viable both technologically and economically. So this is all pointing to the fact that we require new technologies, which are coming on stream easily over the last 10 or 15 years and at an increasing rate today, and the development of new business models. Probably the business model piece is lagging behind the technology a little bit, but is rapidly catching up, and there are lots of new business models that are being spoken of. The idea here is to form, as I mentioned, the grid of grids infrastructure, which allows sort of the best of both worlds, which we learned kind of from the internet. That if we don't want all central computing, yet we don't want all distributed computing, we want to balance between the two. But we want to be able to interconnect and disconnect it when necessary, or island, as we call it in the electrical world, portions of this grid, and yet at the same time enjoy the advantages of scale when it's appropriate, and other aspects like redundancy and so on. So it's a grid of microgrids at the end of the day, or a grid of microgrids and grids, nanogrids, microgrids, and grids that will make this up. And we can kind of look at this in terms of it being structured in tiers. The traditional tier of power generation and transmission is probably up there in the macro grid, all the way down through the midpoint, I guess, easily of distribution in the top tier. And then the in between, which we'll call distribution and collection and sharing layer, tier 2, which includes the vast majority of what people will call microgrids. And then the individual buildings and devices, and even cars, I guess you can throw in the tier 1, that are both the generators and transporters in some cases, where we go vehicle to grid sourcing of energy and so on, in that bottom tier. And much like the internet, tiers can operate on different platforms and with different protocols. But at the end of the day, where they mesh, if you will, is at the points of transaction between the tiers. And in the case of within a tier, it would be between the peers within that tier. So that's the kind of model that we're looking at. So we're going to move away in this fashion over time, fairly quickly, actually, from the sort of the cluster tree network topology we traditionally have in our energy grids today, to a more integrated mesh network, which includes the existing network or a grid and the way it's structured, but adds to it mesh intermediaries and fringes that will make up the entirety of the internet. What this also does, though, is it causes a rapid expansion of stakeholders. So it's not just utilities and regulators anymore. There's lots of intermediaries and service suppliers, new equipment suppliers as this energy paradigm and new model moves into tier one at a greater rate, which is the residential and commercial buildings and other retail and industrial buildings and so on, which then engages the active end users who will start to manage some aspects of their energy use, either actively or at least by software and by default election. And also facility managers and other folks. And I thank Schneider for this picture that kind of depicts that. So where does this all get its smarts from? Well, as I mentioned, it's really all about this ability of computing that now has embedded or allows us to embed computing capability, microprocessor capability, if you want to call it that, at all layers in this scheme. So all the way down to the little devices, as I mentioned, doorbells and sensors and things like that, all the way up to the switches in the smart grid and in the data analytics in the cloud and so on and so forth. So there's various user interfaces that are involved, but it's essentially the smarts in smart energy will come from essentially the Internet of Things and in part the Internet, which will interface with that as a user interface. But as most people know, well, there's some of us geeks that'll probably want to be directly involved in transacting energy, maybe even on a daily basis, just for the fun of it. Most people are going to want to set it up and forget it. So in part, the notion of the IoT is to create a more plug and play or default value where you simply set policies in the system, and then the system real time uses those policies to actually do the controlling and transacting of energy. All of these ideas really come from what we've learned from the internet, where there's some basic tenets of that internet that are virtues that we are going for now that we've learned how it works and we've gained some confidence in its ability to do things for us. The number one is that the internet has really democratized information in a way, and in a certain way, the Enernet, E-N-E-R-N-E-T, is going to democratize or at least localize a great deal more of the energy system, where you have access equality at the very least at for each entity that wants to participate. It's fundamentally based on a localization or a bottom-up public structure. So the more and more as we advance into nanogrids and personal power systems like is being offered by even all the way down at the extremely low voltages of PoE and USB. Some of you operating under the 60-volt level, up through the building domains up to low voltage 1500 volts, and then up into medium and high voltages in the tens and hundreds of thousands of volts. But it is a bottom-up public structure that we're talking about when we talk about transactional energy in the internet. The strength of this transactive mesh network is that there is weak cooperation, meaning that there is no hierarchical control other than through policy and regulation that actually does the day-to-day real-time control of the system. So that's a virtue in the fact that we don't have a dependence or an overdependence on human intervention and other things. And generally, that leads into the fourth quality, which is that again, the idea is to make the grid in its entirety, the internet, something that's self-organizing, more plug and play, where you can come on and off grid when you need to or want to. And that when there is a disruption or a fault in the system, that it's self-healing, works around the fault, and restores the mesh when the fault is cleared, and so on, which gives it phenomenal resistance that that will add to the dependence and use of electricity in doing the work of civilization. So this transactive power management framework then really consists of two important aspects: the grid of things, which are all the buildings and equipment and things that do work, and power sources and the physical infrastructure of the grid and microgrids and so on. But it also now involves the grid of people and how we use energy and how we value the use of that energy in creating these transactive agreements, if you will, to move energy around in the internet. So it includes everything from public utility participation, which has been dominant heretofore in energy and energy services, but also now includes cloud-based service providers, local service providers in both physical and software domains, and the individual prosumers, be they commercial or residential as well. Some of you are aware of, and I may be talking to some of you who are well aware of everything I've said so far, because you've been involved in transactive energy, perhaps through Gridwise Architectural Council, or at least followed it. But there's many resources that are available from the Gridwise Architectural Council, and I just cut and paste a couple of things that talk about why transactive energy might be important to the whole notion of the electrical grid, how it basically works, and then what its benefits are. And again, the most important is reliability, or as I would like to call it, more resiliency of the system, affordability because of the number of choices, and availability that becomes available over time. The fact that it'll enable more renewable energies and other sustainable sources of energy and use, and the fact that it portends to be at least a more efficient system than the one we have today. Energy management will be transacted in integrated information systems and software. And just looking at some of the ways that you might look at the tiers in this. And by the way, I just picked randomly the names over here in the open source Internet of Things, people who happen to, companies who happen to have subscribed to this notion more deliberately. But also the fact that there are energy systems that connect the various elements together, which include both financial, weather and environment, and real-time market elements, and also start to allow you to customize, if you will, the action of the system based on specific vendor elements or their design capability or their platform capability. And it also includes the information, sort of, again, the internet, as I would call it, which is a combination of this physical platform to transfer energy, as well as the management platform, which could be hosted, if you will, by distribution utilities or distribution service providers or other providers, again, to all the way down the 3 tiers to individual consumers. So that's the kind of platform structure we're talking about. And of course, as I mentioned before, the system is really based on computing capability and information and data management and analytics. So you have some real-time systems at both ends of the analytical end and at the use end, and some software platforms in between, many of which will be public, but some of which will be private. Which will allow companies to differentiate their services within this platform. So it can do a lot of things, and we won't have time today to explore all of them, but this is one of the reasons that we recommend that you come to an event like Solar Power International, where you can actually talk to some of the providers of these systems and services. But there's all kinds of new capability that combining the Internet of Things with the Internet of Power is going to enable. And so take advantage of things like the eMerge website or the GridWise website or the SEPA and SEIA websites from Solar Power International. Those are the organizations that sponsor Solar Power International, to learn about more of these advantages. But they're really focused on providing business process support is one of the new outputs, if you will, of an intelligent or smart energy system, both in providing some of the service companies, utilities and service companies, with customer information and segmentation capability where they can improve their services based on real use. Energy campaign for doing things like enticing people to use more efficient devices or manage their energy in a better way. To actually put the hands of some of these tools into the consumer's hands as a service, or as what we would call energy apps, which will help the consumer engage more fully in the whole process and set up their domains in the appropriate way, which includes all the latest things that you can get in computing. These are probably now all taken for granted of these days: energy dashboards and visualization, real-time monitoring, and so on. The impact of doing all this on utilities, because some people say, oh, we're really bashing utilities, or we're trying to get rid of utilities, and it's far from the truth. It's actually the opposite. The utilities are still going to be the core of both power transport and creation. So we have to be careful not to marginalize the investment that we as a society have in our utilities and the regulatory bodies that govern them. But utilities will have the opportunity to actively participate in this transition to transactive energy system or to the internet. And they'll have an advantage since they have millions of customers already, and they can retain and engage those customers rather directly. They can expand their offerings to these new areas of engagement and intermediary service, which include very important things like safety and reliability, and provide customers a much better product offering and array of products and services. And they can form contracts with consumers, much as we do with our cell phones and computer Wi-Fi and web access and things like that. So there's huge opportunities that continue for utilities in addition to their more traditional role. But also it really fuels the, and pardon the pun, but it fuels the creation of a renewable energy industry, because a mesh network of this type, which would probably be non-synchronous and islandable and so on, will really give the opportunity for renewables to flourish, in that most of them are not set up to be real-time dispatchable. So independent power producers and owners of power systems, including homeowners, will be able to get involved in the production and transaction of energy directly with their neighbors in some cases. And of course, folks who are involved in storage of power, which would be much like what was created in the cloud and so on, will also have a new major role. So by and large, the creation of an internet of energy is going to provide more opportunities and a bigger pie, and not really reduce opportunity for any of the current stakeholders or the new ones that are coming on board. There'll be lots of new business models, and I've listed a few here, but it's just scratching the surface, so to speak, of things that we hear all the time, microgrids and virtual power plants and so on, all the way down, but also in power generation and storage, and how those things are used. There's a whole new world of distributed renewable energy and storage and car charging and grid support and so on and so forth, including, and I put down here just for laughs, but I want people to really understand that this is a kind of an unfinished list in a big way. Things like augmented reality, where all that's going to go, and its use of electricity, and perhaps even ultimately in space travel. I think somehow that electricity will play a bigger role actually in our future outside of the current globe. In any case, it is a rapidly developing smart energy marketplace. It includes a lot of new stakeholders with a lot of new opportunities, everything from the physical infrastructure, which means OEMs and technology providers, but also service companies and operating systems and subsystems, and then the folks who regulate and finance and insure and maintain consumer relationships and so on. It's a huge marketplace of developing opportunity. So somebody who's just, and I say just, an electrical service provider today has a huge opportunity to expand the business, or if you're a solar integrator or a solar contractor or a home storage energy contractor or designer, what have you, you're really at the beginning of this huge and expanding marketplace development and ecosystem behind the what we call the internet. I guess the most difficult thing with all of this is to try to predict when it's all going to happen. The good news is it's already happening. It has been happening at least for the last 10 years, if not longer now. Some of the basic things have been put in place. There's even some movement, as we see in some of the lead regulatory bodies in some of the states like California, New York, New Jersey, Massachusetts. I'm sure I'm missing a lot of people, so I don't mean to insult you if you're not in one of those 4 states. But there are new regulatory models being piloted and explored and so on and so forth, some of which are already in place, as well as states who are looking at changing things in following and learning from those leading elements. But as I said, the real question is how fast and when. And I only want to remind people of something, and I borrowed this from Tony Siva. If you haven't read Tony Siva's book called Clean Disruption, I highly recommend it. There may be some elements of it that you may disagree with, but Tony makes a lot of really salient points about what's changing and the velocity of change. So he provided in there a picture of New York City on 5th Avenue, which some of you know runs up to Grand Central Station. I was born in New York, so I'm a little bit familiar with the turf here. But you look at this picture from 1900, around 1900, and you say, where's the automobile? Where's the car, with combustion engine? And there actually is one in this picture, and probably from your computer you may not be able to see it, but there is one out of all those vehicles on the street there in 1900. There's one, and maybe you can see it now if you look closely. So here it is 10 years later. Little slightly different angle of view, but it's 5th Avenue, right up to the Grand Central Station. And the question is, where's the horse? Can anybody see the horse in this picture? This is 10 years later, just 10 years. And think of the huge transformation that took place from one to the other. The one thing I will note about this picture is the one thing that has only changed slightly is the road. And I'll just go back for a second. The road here, although some of New York City was done with cobblestone in the early days and so on, was a relatively smooth pavement. And that's not unlike the electrical system we have, because electrons, by and large, not completely, but by and large will run, at least the bulk ones, will run over wires. And those wires don't need to change in most cases. So, the wires don't know whether the energy is smart or dumb or frankly, where it came from or where it's going to. It's a wire. And that's the way a road is for a car or a horse and buggy. So think of that. And a lot of people said, oh, that's New York. And New York is, they do things quick and maybe not always the right way. But I was in Austin, Texas for a meeting, and I decided to go down to the archives in the library in Austin. And you see the State Building at the end of Congress Avenue here in Austin. And I found a picture from 1900, similar in aspect to the one from 5th Avenue in New York. And you might think Texas was a little bit behind around the turn of the century from New York, but not so. So where is the car in this picture? there is a car there. How about it? So it's very similar to Fifth Avenue. You know, this wasn't on the Easter Day Parade or anything. It was a kind of a regular day of business in Austin. But there's the car in that picture. So very similar. I was lucky to find this picture. And here's the street about 10 years later. Same 10 years. Notice what's happened. Where's the horse? Now, there was no horse in New York 10 years later in that picture, but there is one here, a horse and buggy. So Austin, you could say, was only slightly behind New York. At least I like to say that because I'm from New York. but seriously, again, it just underscores the velocity of change in a technology and how fast it can happen once the conditions are right for it. So everybody who's out there thinking, well, this is going to take a lot of time. I have time to think about it. I have time to learn. I have time to get engaged. Think again, because things can happen real fast, as people in the television industry learned, and people in the film industry, you know, Kodak and others, or xerography and all that. Things will happen real fast when the conditions are right. And all I can say is conditions are nearly perfect at this point. So it's not likely to take long. And here's a roadmap for the U.S. Those of you who are in the U.S., North America, here's one that was done by the GridWise Council that talks about a mature system as early as 2020, or start a fairly mature system by 2020, which is only a few years away, and over the period between 2020 and 2050. But definitely seeing the introduction of some of the pilot work already, and some of the areas of the grid and subsystem deployments that are already happening. So again, think twice if you think this is going to take a long time. It's not likely to, especially since electrons are known to move fairly nicely down wire. And we're not changing the wire for the most part. So the internet is on its way. We believe it's going to provide flexible, clean, efficient, resilient, and affordable, sustainable energy in a very information-supported infrastructure. Most people have latched on to this vision in most quarters, not all, but most. Standards are being created by organizations like eMERGE and the IEEE and the IEC and NEMA and NFPA, and probably left some out here, SEPA and SIA and so on. So there's lots of things happening in the standards world. The ecosystems are developing, and that's why you need to start paying attention, if you can, to the trade shows that are going on, like Solar Power International, and keep an eye out for how this transformation in the system is something that you can take advantage of. One of the things that I remind people of that is being talked about more and more, and is actually showing up now literally on the scene, is the use of direct current. The original or native form of electricity. And a lot of that is similar to what happened in the computer world, the desire to get rid of the need to synchronize. Because as we stay with an AC or alternating current format, the requirement of synchronization and phasing, phase control, and so on is a bit of a burden on a system that is highly articulate and flexible and changeable. So we're going to see a lot more direct current, which is a native production product of things like solar and most other storage devices and so on. I would like to acknowledge in giving this presentation that I stole information voraciously from from a lot of friends that we have in the eMERGE Alliance who are working in all these areas. So I thank the membership, but also especially the folks at DC Fusion and NSYNC who provided valuable information for me to put this summary together for you. So at this point, I'd like to open it up to questions. And Greg, if you're still there, we'll invite people to ask any questions if they want to use the question capability or chat line.
Yeah, so one that came through for you, Brian, it's a little bit general, but you know, there's a lot of talk about moving towards this and having everything work, but what has to happen first? Is it from the utility side? Is it from the developers? How do we make this happen and you know, make who is that first car on the street in New York?
Yeah.
I guess is kind of what the general question is.
Right. Well, the good news is some of the first cars are already on the road, so to speak, is that we've seen a number of companies, both small and large, put out pilot systems. Some have subsystems that actually fit right into this model for individual buildings, or even for individual subsystem like a lighting system or HVAC system or what have you. So think of it like the analogy that always works best for me when I try to figure out how this is all going to happen is to try to remember how the internet came about, what actually happened. So one of the first things that happened before we even knew we would call it the internet and all that, was personal computing came about. So I look at personal computing and say, well, gee, that's like a home that can, put some solar panels on its roof and produce some power, or, a building that can put up solar panels and run its lighting system or something like that. And that's already happening. So elements of this whole thing are at the fundamental piece already happening. If you go to one of my earliest slides here, where I talked about what's changing, and maybe I can do this without messing up too badly here. I'll try to go back. These things that are changing that I think are really the enablers of this all happening. We're just about to the point where renewable energy sources, one of the thresholds we had to get past is what people call grid parity in economics. I don't like to call it grid parity because that can mean a lot of different things, and I can look at some energy that comes off the grid at 5 and 6 cents a kilowatt hour, and other places it comes off at 30 and 40 cents a kilowatt hour. And so what is grid parity all about? But generally speaking, renewable energy is now starting to really prove itself as being economically viable. Sometimes that means that you have to have the right circumstance for it, but in general, I've seen power purchase agreements now going off at something less than 4 cents a kilowatt. So I kind of think that we're kind of past the big hump, which is the renewable energy thing, and a reason that we want to now engage all of these widely distributed sources, distributed energy resources that we can bring to bear. So that puts a lot of pressure on the system when you have all those renewable energy sources coming online for economic reasons, not for just policy or environmental desire or any of those. It's real basic economics. There's going to be a hugely increasing pressure to have a system that can engage those renewable sources properly. And that includes storage, because we all know that the other big holdup besides economics on renewable energy is their lack of dispatchability, or as people would call it, their lack of being able to use them real time, all the time, 24/7. So that problem is being rapidly solved, and products are coming out almost every day now in the domain of batteries and even portable storage concepts like hydrogen production, electrolytic production of hydrogen and so on, which you can do from solar to hydrogen. Now I got it stored, I can move it around and then use it in a car, use it at a plant, and the effluent byproduct is water. So water and maybe some heat, which maybe scavenge in a combined heat and power system. The other thing that's happened very rapidly, and I hope there's some semiconductor companies on the line here, but power electronics. And as I mentioned, particularly in the area of power conversion and power management, high power switching, I guess, is one of the areas that has rapidly been improved. And these devices are using less and less overhead, or less and less parasitic effect on the energy itself. So they're very efficient devices, and increasingly so. So all these things are kind of in place. It's really a matter more of now the economic or ecosystem coming together And a lot of that's happening through conferences, and some companies, both small and large now, are starting to offer very unique and novel systems, microgrids in particular, nanogrids, lighting systems, all of which fit into this kind of footprint of the internet. Think of them as peripherals that you started to first attach to your personal computer. Eventually, and the missing piece, because in some respects we've been down this path once before in the United States and North America, back in the 20s and 30s, there were a lot of microgrids. In fact, as many as 2 million of them reportedly installed at farms and rural houses in the middle part, most of the central part of the United States, which were never connected together. So that was like, you can imagine that at the time, if we had personal computers and all the capability that we got from personal computers as independent islands of data processing and capability and information management, and never connect them together in the internet, would we go back to then just libraries and other things where people went to get information? So I think that that's going to be different this time. So all of these microgrids and nanogrids that people are putting together will come together and be interconnected in the so-called internet. And part of that, I guess, is the big missing link here is education. And I think at the end of the education line, or in the middle of it maybe, is the desire of people, early adopters, and then the silent majority to really desire the fruits of all of this, which is energy independence, articulation of energy systems, the greater use of energy in your home, electric energy in your home. And by increasing electric energy, a lot of times we're decreasing the net amount of total energy that we're using, because we get energy, first of all, supplemented by solar, but it can become more efficient in terms of its production and use as electricity, as opposed to burning, whether it's coal or wood or fossil fuels or oil and so on. It becomes a much more efficient conversion of the energy stores that we might have, or energy sources we have. So I don't know that there's one single trigger. I think that it's already started, and a lot of it is going to be consumer desire, consumer awareness, and as companies start to show their quote unquote apps, applications for how a smart energy system will benefit the consumer, will benefit the building owner, the building manager, then it's just going to accelerate this rather rapidly.
Okay. Thanks, Brian. And one follow-up to that before we get to Bruce's question here. So then I think, again, this is a little bit general. Where are the business opportunities? So if you're looking at this, maybe from even like a contractor or developer, what should they be looking for or pushing for when they're developing contracts and looking for new business? How do they get to this point?
Yes, in the theme of follow the money, I'd like to say follow the wire. So if you're, for example, if you're a solar integrator, solar contractor, and you're putting solar panels on the roof of homes or buildings or commercial buildings, follow that wire. It doesn't stop at the meter or at the net metering point, kind of, some people go to the common point of connection with the utility. It goes inside the building, and inside the building, there's going to be a whole new generation of systems and apparatus to run that building. So if you're a solar integrator, think of where that wire goes and how you can follow that wire to new opportunities. If you're an electrical contractor, I guess the opposite applies. If you're inside the building, what's going on outside? What's going on with energy management? What's going on with energy storage, electricity storage, and so on? How can you participate, expand your product line into those areas? What that means for you is two things, though, in general, and this is applied to just about anybody who wants to expand their business. You have to learn what those opportunities are, and that's where education, joining the appropriate associations like SEPA and SIA and so on, to learn about it. And then then at finding partners, finding creating a supply chain that can add or enhance your current product offering. So I've seen a lot of, more recently now, a lot of solar integrators, for example, who are now also offering energy management systems, energy storage systems, even separate from their solar offering. I've seen even them offering hydrogen or wind, if they were traditional solar, because the whole energy domain is expanding. Solar will probably be one of the most dominant ones. And so you don't ever want to take your eye off solar. It's going to grow and it's going to be big. But look at, it isn't right for every application and every circumstance. So keep your eyes open for other opportunities as well. So those are the two things: is education and look to create a new supply chain relationship with other parties.
Okay. This next question comes from Bruce. There's a couple parts to it, so I'll try to break it down here. But he said, shouldn't we first make maximum use of highly dynamic pricing at the meter before spending lots of money on complex, expensive systems that involve bidding and contracts?
Yeah, I'm not sure that that's in conflict with anything that I've espoused here. Yeah, you always want to take the low-hanging fruit first. So a lot of that depends on the regulatory apparatus. In other words, if the regulatory apparatus starts to differentiate, uses of electricity in such a way that you can create a new value point in the system. But right now, most of the regulatory apparatus is focused around a single value, which is pennies per kilowatt hour. And I guess in the commercial world, you can say, okay, there are demand charges and other charges and so on and so forth. But yeah, this kind of an infrastructure, this versatile infrastructure that really puts together the same kind of mentality as an intra apparatus as well as an inter apparatus, really will first always want to take the low-hanging fruit. And if that's just differentiating price points, then so be it. But I don't know, the notion that this is all expensive. I guess you could say that cellular phones were expensive and computers were expensive. Computers expensive as compared to paper and pencil, or cell phones as expensive as compared to rotary dial phones. I know I just had to pay for a phone. It was like $700. I don't think the rotary phone ever got close to $70. But you have to look at value and not just price point, and saying that yes, it could be more expensive, but how valuable is it? Particularly as electricity, as I like to say, the electron is really the future currency of civilized progress. In other words, we're depending on what creates value in our society. In most cases, is something that produces wealth. Wealth can then support well-being, good health, and so on and so forth, and be passed on, and so on and so forth. So the first thing you want to do is say, do I have a system that can create new value? And I think what we're talking about here in terms of smart buildings, it's not just smart to be cute or smart to be cool. As I show people how I can talk to my my Amazon or my Google Home and get it to play YouTube on the TV without touching any buttons or dials. That's kind of cute. I don't know how useful it is. Sometimes it's useful if my hands are greasy and I'm working on the lawnmower and I need a YouTube video to show me how to change the carburetor. Not having to turn on the TV and all that is a pretty cool thing, which I've learned to take advantage of in the smart world. But it's really the value that comes from developing a system that's much more capable. So that would be my answer there. But yeah, always low-hanging fruit is always the first thing you want to grab.
Yeah. So I think that's all we have for the questions here, just in the sake of time.
Okay. I would want to just mention and underscore, if if you really haven't seen a microgrid in action at Solar Power International, we do a demonstration. We'll be giving a preview of that in our next webinar on August 2nd. You might want to jot down that time, and you can sign up for that. There'll be a link to sign up for that. We'll be talking more about the business opportunities in that webinar. And we'll also be giving a preview of the show itself, which includes, as I mentioned, Solar Power International this year, as well as North America's largest energy storage trade show, Energy Storage International. We'll have a Smart Energy Microgrid at the show, which eMERGE is facilitating, and it also is going to include, for the first time, the world's largest hydrogen fair. It's coming to us from Europe, but going to be here in the United States at the show. So it's going to be a phenomenal place to see all of these things in action and how they integrate into this smart energy area. We will have a live microgrid there that'll be operating with a variety of people's components in an interoperable fashion. So it's not one company's solution, it's a multiple company solution that will be powering a part of the show floor in the smart energy area of the show floor. And it'll be right inside the main entrance. And if you're interested as a supplier of products or services, there's still opportunities to get involved with the Microgrid Marketplace and demonstrate your products there. It will have a smart energy theater or stage where there'll be presentations and some discussion panels that will be talking about microgrids and the grid of grids and the internet and so on. There'll be some tours throughout the show with smart energy and energy storage, educational tracks, and so on, as well as some keynote speakers at our opening event and some special after-hours events. So if you're interested in that, please let us know. And if you have any questions, please jot us a note. And all of that's coming up at Mandalay Bay in September, which will house the North American Smart Energy Week and in particular Solar Power International. Okay, Greg, that's it for me.
All right, and then one last piece of housekeeping here. I just saw a question from Jay Page. As far as slides and recording, we'll send a recording of this after probably the next day or so. We just have to download it and re-upload it. And then the dates for the next webinar, we just had that up, and I don't want to tell you the wrong one.
It's August 2nd at 2 p.m. I'll bring that up if I can back up here for a second, real quick. And
we can send a recap of that too, so you have the time and date. And also, if you go to solarpowerinternational.com, kind of in the middle, there's like a latest news area. We'll post it in there so you can go register. But if you have any questions, just reply to the email that you'll get the next couple of days here, and we'll be able to help you out.
Yeah, and we'll provide a link at the eMERGE Alliance website. If you're familiar with that, it's emergealliance.org, and we'll also have a link there that you can link into. And as I said, if you're interested in participating in the demonstration at Solar Power International during North American Smart Energy Week, please drop us a line, again, either to eMERGE Alliance or SPI, and you'll see the contact information on those websites. But send us a line that you're interested in. We'll be sure we're just starting the meetings to finalize the plans for that. It'll be a phenomenal promotion and is attended by